Hi friends, today we are going to consider another design pattern taken from Unmesh Joshi's brilliant blogs on distributed systems. This pattern is called state watch pattern. In this, let's suppose we have multiple callers or multiple systems who want to monitor a particular set of keys or a particular set of states on a key value store or in a consistent core systems. Let's say we have key value pairs as K1 V1, K2 V2 and K3 V3, and callers 1, 2 and 3, they want to consider or they want to keep track of what is the current state of K1, K2 and K3s. Now, the most naive way we can think of is we can continue polling on these values from these clients, and as soon as the value changes, it is going to the callers are going to get the updates. They're going to know that the values have been changed. Changes can be in the form of addition or removal, or it can be modification, right? Keys can be added, removed, or modified. Now, polling is one of the ways, but let's see what are the drawbacks of pollings. So, if caller 1 wants to monitor K1, K2, and K3, it will have to raise 3 connections to the consistent core or our KV store, and this way, as the number of key values in our system and the number of callers increase, it is going to multiply the number of polling connections that are going to be required. So each connection is going to take some resource of your system, and the number of connections are also limited. So this is not the best way forward. Now, what are the other ways where we how we can watch the states in the most optimal way? Now, one of the ways is called state watch pattern, as the name suggests. In this, what we're going to do is we are going to open a single socket queue. We are going to open a single socket connection to our key value store, and we are going to ask the consistent core or our system to register our watchers. Let's consider this. Let's say we have caller 1 is C1, caller 2 is this is C1, C2 and C3. Rather, I should not say caller, I should make these connections that are being made as C1, C2 and C3. Right. Now, what we want is we want C1 to look for K1. C1 wants to keep track of key K1. So we are going to add, this is the watch list that is maintained by this consistent core which is hosting the keys that are being watched. So C1 is tracking K1. Connection 2, this connection is tracking keys K1 and K2, and connection 3 is tracking K3. This is the watch map. Now we will also have to create, or consistent core also has to keep reverse map where, or rather it is the forward map where keys 1 are being watched by connection C1 and C2, keys 2 are being watched by C2, and keys 3 are being watched by C3. So as soon as a new watcher comes, it is going to be added in these two maps. So when the value changes, all the consistent core has to do is, for example, key 1's value changes, it comes to know that these values are being watched by connection C1 and C2. So it is going to send the updates across these connections. And along with the update, it is going to inform on the channels or on the socket connections that the key K1 was changed. Now let's take another scenario where we want to remove this caller, that this caller is deregistering itself. So this connection is going to be deregistered. Now the consistent core is keeping track of what are the keys that are being watched by this connection. C1 is watching keys K1. So all it has to do is it has to remove the watchers. It has to remove this entry as well as remove one of the watchers, that is C1, from the key K1. This way, all the resources that were utilized or that were allocated to connection of caller 1 are being released. Now let's consider the case where we have hierarchical keys. Now in this case, let's say we have keys with the name /server/1 /server/2 /server/3. It denotes the servers that have been registered with the consistent core or KV store. Now there is some caller, let's say caller 1 wants to know what all if there is any change in the servers that are registered with the consistent core. Let's say a server was added, server was removed, or there was any modification in any of the keys of the servers /server/something. This is also possible, where what the caller is going to do is, rather than having watches on all the hierarchical values by finding them, but that is not possible because keys can come and go, and the caller will have to keep itself updated with the keys that are present. So what it is going to do is, it is going to do a hierarchical watch in the consistent core. It is going to create a watch on /server. Now consistent core is going to keep a track that when a value is changed, for example this value is changed, it is the key that is changed, this key is changed, it is going to notify not just the keys, not just the connections that are linked to this key. It is going to notify, for example, let's say let's take an example, /server/1, and it is listening by connection 1 and connection 2, and /server is being watched by connection 3. So any change in connection server/1, this is the key. It is just a hierarchical key, or rather a key where you have different directory structure. It will be informed to connections 1 and connections 2. An update will be sent to connections 1 and connections 2. Besides this, what it is going to do is, it is going to traverse this hierarchy. It is going to remove this and check which which connections are being listened by this key. So it is going to find that /server is being listened by connection 3. So it is going to send an update to connection 3 as well, right? And if, for example, we had /a/b/c /a/b and /a, okay, so if any change in this key and we had hierarchical watches available, then it is going to be sent to all the connections corresponding to this key. Then after removing C, all the connections for this key, and then after removing B, all the connections to this. So these are the hierarchical watches where you can get updates or of addition, modification, or removal on keys of your childs as well. So A is going to get all the updates of his child. That is, this is his child and this is his child, right? One thing to keep in mind is, when, for example, our key was /server/1 and the values were changed, it is going to be notified to this as well as this. But when C3 is going to receive the event, it has to be informed what was the actual key that changed. Actual key that changed was /server/1, and but it was watching on /server. So /server/1, or whatever the actual key was that was changed, has to be informed to the connection or to the client that has set the watchers, set the state watch. There can always be failures when you're using distributed system, or rather any system failures inevitable. Now let's suppose client C1 was there was a key K1 which was being listened by C1 and C2, and there was key 2 that was being listened by C2. Now let's find out what are the different connection mappings. C1 is watching K1, and C2 is watching keys 1 and 2. Now, what is going to happen in this case? Let's suppose our client C1 dies. This connection is lost, and after some time, when client C1 comes back, let's suppose C1 had these events were 1, 2, 3, 4, 5, 6. There were 6 events that had happened on key K1, but client C1 had only listened to events till 3. It had only got events till 3. So our KV store or consistent core should ensure that whenever client C1 comes back, it has to keep the record of events that are happening on the keys or that are happening on the watched states. And as soon as the client reestablishes the connection and it has established that it is a reconnection, then it can ask that I have data till 3, give me all the data that has happened after the event 3. 3 is not the value, but the sequence of events that has happened on key K1. So in this case, what the consistent core is going to do is it is going to send these values on this connection, or rather these events. These are not the values, but these are the events. For example, in event 4 the value was modified, in event 5 the value was removed, and in event 6 the value was re-added or key was re-added. So it is going to send this. So when client crashes, and when it comes back, it is going to tell the consistent core till when the client has the values. Then post that event, a consistent core has to send all the events that has happened after the client lost the connection. The thing we just discussed, in which all the events that are happening for a particular key are getting numbered, and the client is sending the event number after which it wants the event. This is the type of applications of write ahead logs, wall entries, where the server or the consistent core or key value store is going to ensure that all the changes in the keys or all the changes are written in log write ahead log files with a particular offset for every value inside the log file, and clients can demand or client can request a particular entries after a particular offset for their watched keys. Keeping these write ahead log file entries for all the changes that are happening on any keys can get out of control, because there's a limit on how much data that you can store. These events, for example, let's say your client C1 or connection C1 goes down, and and after that 1000 events have occurred on the particular keys, or 1000 events have occurred on this key. How much data should the KB store or consistent core store for a particular key? That depends on your space constraints. For example, let's say this client was down for 3 days, and it is a there are very frequent changes in the KB store. So it depends on your use case, how much older data you want to store and how much older events you want to provide to your client once it comes back up. There are some scenarios, or there are mostly, if it reaches a particular threshold, then you won't be able to recover, or you won't be able to send all the events that have happened after your client went down. So it depends on your space requirements, how much older data you can provide to your clients. Another way of storing or another way of having multiple events on a particular key is by keeping versioned key value stores. Versioned key value stores, where you are having different version for a particular key value, and client C1 can provide the version that was there when it was watching on that key, and then once client comes back up, the server or KB store is going to send all the events of or all the version changes on that keys that client C1 was watching. All in all, to summarize, in state watch pattern, all you do is you want to watch a particular set of keys, you tell the consistent core that you want to watch a particular set of keys. When anything changes, consistent core is going to send the updates on a single channel. Now this is very important. It is going to send the updates on a single channel only, and it is going to keep the events that had happened on all the keys, so that even if you lose the connection for a particular threshold duration, and once you come back online, then the consistent core is going to send you notifications or event changes after you went offline. uh, it is going to send all the event changes that came across after you went offline. uh, that is all for the state watch pattern. I hope you enjoyed the video. Thank you and have a nice day.